If your engine is running right now, it is producing 20 to 30% less power than it was engineered to deliver, not because it's old, not because you've neglected it. Because there is a layer of carbon baked onto every intake valve in your engine right now, your dealership knows exactly how it got there, and they have a $450 service on their menu designed to clean it up. Every 30,000 to 60,000 miles. For the rest of your car's life. This is not wear and tear. This is not bad luck. This is not a design oversight they're still working to fix. This is the power drain. An engineered failure built into the combustion system of almost every car sold since 2010, specifically designed to generate a maintenance revenue stream that didn't exist 20 years ago. And once you understand how they built it in, deliberately, with full knowledge of what would happen, you'll never look at a dealership service menu the same way again. Here's how the engine in your car actually works. Every time an intake valve opens, it's supposed to be bathed in a fine mist of fuel and air. In older port-injected engines, the kind that powered almost every car sold through the 1990s and early 2000s, that fuel wash kept the back of the valve clean. Hydrocarbons burned off. Carbon had nowhere to accumulate. A 1,999 Toyota Camry with 220,000 miles on the clock will often have intake valves that look nearly factory fresh, just from the natural washing action of 20 years of port injection. Your 2014 Ford Explorer with 75,000 miles might have valves so caked in carbon they can't seal properly anymore. The difference is a single engineering decision made in boardrooms, not engineering labs. Gasoline direct injection. GDI engines inject fuel directly into the combustion chamber, bypassing the intake valves entirely. The result is better fuel economy numbers for the window sticker, better horsepower figures in the brochure, and an intake valve that receives zero fuel wash. Not reduced fuel wash. Zero. From the day it rolls off the assembly line until the day it's cleaned or scrapped, without that fuel wash, the crankcase vapors, your engine recirculates back through the intake oily combustion gases, carrying unburned hydrocarbons, and moisture condense on the back of every intake valve, and bake into a hardened carbon crust with every heat cycle. At 30,000 miles, it's a thin film you can wipe off with a rag. At 60,000 miles, it's a crust that requires a chemical soak to break down. At 90,000 miles, a 2011 BMW 335i with the N55 turbocharged engine, one of the most popular performance sedans of its generation, will commonly show carbon deposits thick enough to reduce airflow into the cylinder by 15 to 25%. Less airflow. Less combustion. Less power. More throttle input to compensate. More fuel burned to produce the same acceleration the car could achieve at 20,000 miles. Your engine working harder to deliver less. Think about what a 20% reduction in airflow actually means in your daily driving. When you merge onto a highway and the engine hesitates a half second longer than it should. When the fuel economy that was on the sticker has been dropping a quarter mile per gallon every year and you've been blaming traffic. When the car just doesn't feel the way it did at 20,000 miles and every mechanic tells you that's just how older cars are. It's not age. It's carbon. And it's been accumulating since before your first oil change. A proper dealer induction service, walnut shell blasting, intake cleaning, the full procedure runs $400 to $600 depending on the make and model. Recommended every 30,000 to 60,000 miles. On a car you'll own for 10 to 12 years, that's $1,600 to $2,400 in induction services alone, before you account for the additional fuel consumption, the turbocharger wear, the injector stress from compensating for a throttled engine. Every single dollar of it preventable. Every single appointment on a calendar your dealer manages. This isn't maintenance. This is a subscription they enrolled you in when they handed you the keys. But the GDI carbon problem is just the bait. The real scam is who knew about it and when before they put the engine in your car. Gasoline direct injection technology didn't arrive overnight. BMW was running GDI systems in European markets in the early 2000s. Volkswagen had the FSI direct injection system in production before 2004. The thermodynamic data on carbon accumulation without port injection was documented in engineering literature before most of these engines reached the American market. The engineers who designed the intake systems on the Ford EcoBoost, the Chevrolet 2.0T, the Honda 1.5T Turbo, the Hyundai Theta 2, they had access to the same data. They knew, with engineering certainty, that without a fuel wash on the intake valve, carbon buildup was not a risk. It was a scheduled outcome. The solution existed before the problem went mainstream. A secondary port injection system, small, inexpensive fuel injectors mounted upstream in the intake ports to wash the valves the way older engines always did, is called dual injection. And it works. Volkswagen was quietly incorporating it into higher-margin platforms by 2012 with the MQB architecture. Toyota deployed it as the D4 ST system on the 86 and certain Lexus applications. Audi used it on select S-line models. These are production solutions, in vehicles rolling off lots today, that eliminate the carbon accumulation problem at the engineering level. Not reduce it. Eliminate it. The mass-market vehicles didn't get it. The Ford EcoBoost that powered millions of F-150s and Explorers. The Chevrolet Equinox, with its 2.0T. The Honda Accord with the 1.5T that became one of the best-selling vehicles in the country. Not because dual injection was too expensive. The hardware cost for a secondary port injection rail on a 4-cylinder engine is $60 to $100 at manufacturer scale. Not because it wouldn't fit. Because the vehicles most likely to need induction services, the high-volume mainstream models owned by drivers who don't know what an intake valve is, were exactly the vehicles funding the service revenue that dual injection would collapse. The induction cleaning service market generates an estimated $3.2 billion per year in North America. That number exists because manufacturers built a system that guarantees the demand for it: every car sold, every mile driven, every heat cycle that bakes carbon onto valves that a $60 engineering decision could have kept clean. The 2017 Honda CR-V with the 1.5T turbocharged engine, one of the best-selling vehicles on the road during its run, had documented carbon buildup in owner communities by 40,000 miles. Honda's official recommended response: an induction cleaning service. Available at your dealer. $450. The carbon didn't form because you drove it wrong. It formed because the valve cleaning system that used to come standard was removed from your car before it left the factory. But here's the layer that reframes everything you just heard. The manufacturers don't just profit from the induction service, they profit from the power loss itself. Every percentage point of combustion efficiency lost to carbon buildup is a percentage point your engine compensates for. You press the accelerator a fraction harder. The fuel management computer holds the injectors open longer. You use more fuel per mile. The turbocharger spools harder to push air past clogged valves. Turbocharger replacement on a modern 4-cylinder turbocharged engine. $900 to $1,800 at an independent shop. $2,400 to $3,500 at a dealer. Fuel injectors that are compensating for reduced airflow develop lean running conditions that accelerate tip wear. Injector replacement. $600 to $1,200 for a set. The power drain doesn't cost you once. It costs you at the pump every week. It costs you in the service bay when the induction cleaning is due. It costs you at the parts counter when the turbo that was overworked goes. And it costs you on the trade-in lot when a car that runs rough at 100,000 miles is worth $3,000 less than one that doesn't. You didn't lose 30% of your engine's power by accident. You paid $35,000 for a car engineered to take it from you, on a schedule, for profit. If this investigation has already changed how you see the service recommendations waiting at your next oil change, subscribe now, because what follows is how to opt out entirely. And what it actually costs is going to make you furious. Here's the bypass, and it starts with a part that costs less than dinner: an oil catch can. A small canister, sometimes called a crankcase breather filter or PCV separator, that intercepts the oily vapors coming out of your crankcase before they reach the intake manifold. Before they hit the back of the valve, before they bake. A quality catch can from a reputable aftermarket supplier runs $40 to $80 for the hardware. Installation on most 4-cylinder engines is an hour of labor, $80 to $120 at an independent shop. Total investment, $120 to $200, once, for the life of the car. Compare that to $450 every 40,000 miles. Over a 150,000-mile ownership period, the catch can save you between $1,200 and $1,600 in induction services alone, before you factor in the fuel economy, the reduced turbo wear, the injector life. The math isn't close. Fleet operators have run catch cans on high-mileage gasoline and GDI-derived engines for decades. When you're managing a fleet of 20 service vehicles and tracking cost per mile as a business metric, a $150 catch can installation versus $500 in induction services every 2 years is not a philosophical debate. It's the only logical answer. Independent mechanics who work on performance BMWs, Audis, and Volkswagens, the shops that see these engines at 150,000 and 200,000 miles, fit catch cans on their personal vehicles as a matter of course. They've seen what the inside of an N54 looks like at 80,000 miles without one. The second part of the solution costs even less. A concentrated polyetheramine-based fuel system cleaner, the same base chemistry used in professional induction cleaning machines added to the fuel tank before every oil change, keeps the fuel injector tips clean, helps with light deposit control on valves, and maintains combustion chamber efficiency between services. Available over the counter at any auto parts store. $10 to $20 a bottle. That's $40 to $80 per year in preventive chemistry versus $450 every other year in reactive service. But if you're already past 60,000 miles on a GDI engine and you've never had an induction service, the carbon is likely already there. And here's where the dealer model breaks completely. Walnut shell blasting, the actual mechanical process that physically removes hardened carbon deposits from intake valves, is not proprietary dealer technology. It requires a specific tool and technique, but any competent independent mechanic trained in the procedure can perform it. The going rate at a well-equipped independent shop is $150 to $250 on most 4-cylinder engines. The same procedure. The same result. The same valves. At a dealer, that service runs $400 to $600. The only difference is the logo on the building. Run the actual numbers over a realistic ownership period. 150,000 miles. 10 years. The dealer path, 3 to 4 induction services at $450 to $600 each, plus the compounding fuel economy penalty, plus the accelerated turbocharger and injector wear. Conservative total, $2,500 to $3,500 in preventable costs. The catch can path, $150 to $200 installed, $15 to $20 per year in additive, 1 walnut blast at an independent shop if you're starting with existing buildup. Total over the same 10 years, $350 to $450. The gap is $2,000 to $3,000 per vehicle. Multiply that by the 40 million GDI vehicles on American roads right now, and you start to understand why the manufacturer service bulletins never mention catch cans. If every GDI vehicle owner understood catch cans, fuel system additives, and independent walnut blasting, the $3.2 billion induction service market doesn't slowly decline. It collapses. That's why no service advisor has ever mentioned a catch can across the desk from you. That's why the owner's manual recommends throttle body cleaning and cabin air filters, but says nothing about the crankcase vapor stream that's been depositing carbon on your valves since 15,000 miles. That's why the solution is $60, and the service it replaces is $450. The math only makes sense if one side doesn't know the other option exists. The catch can is available. The additive is on the shelf. The independent mechanic with the walnut blaster is in your city. And the manufacturer built their entire induction service revenue model on the assumption you'd never connect those 3 dots. You didn't buy a car. You signed a maintenance contract written in engineering decisions made before you saw the window sticker. Share this investigation with everyone you know who drives a turbocharged engine made after 2010, because the induction cleaning recommendation on your dealer's next service sheet is a $450 bill for a problem a $60 part prevents. And in our next investigation, we're exposing the break-in protocol that every manufacturer quietly removed from the owner's manual. The one that independent engine builders say adds 100,000 miles of life to a fresh engine. The reason it disappeared has nothing to do with modern metallurgy. It has everything to do with who profits when engines wear out on schedule. Click the video on your screen now.